This is GST 7130, Module 8 on charts, web development, JSON, and a little bit on HTML tables. So I'm your instructor, Robert Hewlett, and you can contact me via the email address below. The learning outcomes for this lecture, although not an absolute list, you should be able at the end to, distinguish different JS charting libraries, describe a web development server. So I'm going to talk a little about a couple ways to do it. There's a whole bunch out there that you can use. We're going to use a simple one. In that, I'll show you a couple different ways to make it happen. I'll talk a little bit about Chart.js. This is the charting library that we'll use in the lab. I'm going to talk about more Chart.js categories from getting beat up by the API in preparation for the lab. Definitely had some epiphanies about certain types of charts, and you can kind of group them and then understand some of the behavior and how to set up the data for them. We'll describe some of the key components of Chart.js. Much like other charting libraries, there's a bunch of hooks to get the JavaScript in. There's either some div or canvas you got to hook into. So we'll talk about all that. We're going to talk about JSON as a data source. So it is, I guess, today the data source for web applications and even some mobile applications as well. Talk a little bit about different techniques to get data. When you get data in a web environment, it's done in an asynchronous way. Old school callbacks and stuff. We're going to talk about the promises have been around for a little bit. They show up even in the Easterite JavaScript API 4. So a lot of promises in 4. New technique called async await. We'll talk about that. But then it's just, I think I posted some links into some YouTube sort of things where like a sort of a parody of a senior JavaScript developer and then a reaction to that. And, it's mentioned in the reaction, if you watch it, they talk definitely about async await and then rewriting their code back to promises. So promises came before async await. Async await showed up, but then it depends how you like to code. And when you look at the code, like if you had to maintain it or explain it to someone else, it all depends, right? It can get kind of confusing. But my advice would be if a certain method clicks in your head for you, you should probably adopt that, right? As simple as that. And there's lots of ways to get something done in JavaScript. I'll talk about built into await and promises is the JavaScript fetch. So we'll do the fetch a couple different ways in that. And we're talking a little bit about for loops. Now I say loops, maybe I should just call it JavaScript loops. There are some loops built into the language for sure. We'll talk about those. But in something like arrays, they've added a bunch of methods which basically are embedded loops to help you get something done. So you don't, use a lot less lines. So if you need a lot of loops, just loop for an array. So what they just did is built a bunch of options into arrays today that have, like I said, a built-in loop. So there's some different ways of looking at it. I might actually edit this slide afterwards and take the for loop out and just talk about there's different ways to loop, and depending where you are and what kind of structure you're dealing with, you may have some built-ins, we'll call them, that can help you out. So we'll talk about some JavaScript charting libraries. There's a lot of them, right? And so this is not the full list, just so you know. AM charts is one, AnyChart is another. Chart.js is the one we'll be using in the lab this week. Chartist looks very nice, responsive in that, responsive for mobile, right? So D3, been around a while. It does more than just the standard graphs that we're used to, right? Lots of things can do bar charts and line charts, but D3 has some very interesting visualizations in that, I mean, just a lot. They just don't stop at the regular charts. You can get lost in the amount of visualizations they have. D3 has been embedded into Data Plotly, which is an extension for QGIS, which adds a bunch of really cool graphing to QGIS. But D3, like I said, well, my hesitance and the big long pause there. It's a bit of a beast because it can do so much in that. And it's just not your regular charts. There's lots of, hierarchical ones. You have to see them. There's lots of ways to look at data and that sort of thing. And that. So it is my thing is baby step. It start out with something like charts or Google Charts, and then move up to D3 in that. Google Charts I've used in another course in a database course in that. Google Charts and Chart.js pretty close to what they can do. They do it differently, but pretty close. But D3 is this step up above all the others. There's HighCharts, Plotly, in that. So there's lots of little camps that have lots of charting libraries. A lot of them are free, so you can get down to developing and adding charting to your web app if you want in that. Okay, but to really test some of this stuff in a proper way in that, and that's not being judgmental, the proper way is just so that when you deploy this in the real world, you want to be as close as you can to that, right? But there's a trade-off. You want your development server to, be simple, start up fast, but act like you have a website in that. So, and act more like the real-world environment. That's what you want for prototyping and developing, is to be as close as you can to the real thing. But at the same time, the real thing could take days, weeks to set up. And you're like, no, I need this installed like in 30 seconds or a minute so I can get going. So there's no big compromise and trade-off there in that. In terms of development server, there are these things of like where you develop and then you test and then you roll it into production. And production is the real world. And so dev and test we try to get them close, but often they're not. And so then you find out when you deploy it, oh, there's a firewall issue, or okay, the library is not coming through, or okay, it's different because we have cross-origin requests. So there's always something that comes up. But what you want, like your dev test, is you want to be pretty close to how a real web server works, so that you don't have to change a bunch of code to get it into production. And on the dev side, the concept of write some code, test some code, debug some code, you need that to be as streamlined and as quick as possible. It's really important to take any friction out of that cycle, because this is where you really start to slow down or speed up depending how your dev server behaves in that. So staying sane as a developer, important. So that write, test, debug cycle needs to be fast in that. So setting up a local dev server helps. So if you're in VS Code, it's just not the browser opening up like a URL where you can see up in the address where it goes, //file : because it's not going to behave like it would on the web, right? You want something that does a little bit of, a get post in the background and send some data back to you in that. And you want to, and so for that to happen, you do need to what we call spin up it can be a tiny footprint, but you got to spin up a little bit of a web server and just to serve up the pages like they would be served up in the real world, right? There is some development you can do by just opening up local HTML and JavaScript files, and the browser does okay, but every once in a while, because that's really not how the real world works, then our stuff in production starts to break. Right? Still not the real world, but closer, right? Luckily, several recent options. So if we're going to talk the latest web development, we're probably talking Vite Snowpack. So I played with Vite a bit. There is a thing about working on network drives. I'm not sure if they fixed that bug. It cropped up earlier in the year in that. I think it's related to something called ESBuild because the Webpack rollup part of it has no problems. So we'll use something that it's got a lot of fancy stuff in there to make things fast. We'll talk about that in a later slide, hot module replacement and that. But these would be the brand new shiny tools that are really help out developers and really help you really shrink that write test debug thing. Basically, as you type code in VS Code, if you have autosave on, you start to see it appear in the browser. You don't refresh or anything like that. So it's really nice in that. However, we're going to stick with HTTP server, right? Old but still good, in that. Depending how you do it, it can bloat your project a little bit. It's going to add 3 or 4 megabytes to it, a bunch of directories and files. We'll talk about all that. But this is the one I'll be demoing in my lecture demos. And so if you're curious in that, that's the one I'm using. And that, but yeah, if that one network drive bug was gone in Vite, we would actually be doing this on the War desktop and other places. But because we use the Z drive, and that is a network drive, the bug just basically hammered that whole concept. But at home it would work, right? If you're working off a local drive inside your laptop or desktop, or even one that's attached via USB or Thunderbolt, that'll work. That seems to work fine. It is a network drive issue in that, but the bug could be solved, but I haven't checked in about a month in that. So busy, busy, busy. So how would you set up a dev server? The one I'm mentioning, ATP server, well known in that, and even Vite and Snowpack, well known. Even those products are going to need the product I'm about to mention to you. So, and that you need to install Node.js. A lot of these little dev servers are actually Node servers, and that. Now, technically, it means it's a JavaScript backend server or written in JavaScript. For you, that, I mean, the way we're going to use it, we're not going to notice that part, even though we're doing JavaScript. We just need something. We don't want to have to install Apache or Nginx or something like that, configure those beasts. We just want a quick server to pop up and behave like a production web server, a little bit in that. So a lot of modern web development relies heavily on Node, and therefore NPM, NPX, Yarn. These are all package managers for Node. And so there's a ton of JavaScript going on, not just up in your browser, but in the back-end server side as well. And so we can take advantage of some of this stuff that's been pretty well built and tested by, tens of thousands of people in that. So when I do this kind of thing, I'm going to be working in VS Code, so you can get that installed as well. VS Code was built for the web and TypeScript and that, so it has a lot of nice goodies for HTML formatting and IntelliSense and that. But you still need, that's to help you write code, but you still need to test it against a server in that. So you do need to get that installed. You need to create a project to open up a folder. Have a good consistent directory structure, kind of like we did, so that exercise in the first lab. I mean, it's real. Like, you want to have, okay, what am I going to call my CSS folder? What am I going to call my JavaScript folder? What am I going to call my data folder, my image folder, my icons folder, that sort of thing, and just have a consistent structure that you follow, because it just makes you faster in the end, right? So you want to be fast, right? So say we have VS Code installed, we have Node installed, right? You can just open up a terminal window in the root folder of the project in that. And you can just go, it never hurts before you do this actually, is to type in node space _version, the word version, to make sure, okay, I installed Node, can VS Code see it? So I'll try to do that check in the demo, but it never hurts to actually, like I said, check that you have Node and that what version am I running. So the version rolls fast. They're up in the 18s as we speak today. They could be higher by tomorrow in that. So even before you do this little step here, it wouldn't hurt to actually just go node space -- version, the word version, just to say, okay, is it installed and what version am I running? Or what version does VS Code see? Maybe a multiple installs, who knows? And so, and the second gets into, if you run into a bug and bug land and that sort of thing, you really need to know what versions you're on. Now, there's something you can do called NPX HTTP server. And so what that's really going to do is it's not going to install it in your project, but it's going to quickly download it from the web and run it. right? And so what this means is that your directory structure stays light, not bloated. So it's not going to install a bunch of node modules into your project, but it does. There's that little hit where, hey, it's got to run out to the internet, which means you got to have an internet connection while you're doing developing. Pull down HTTP server node package, right? Kind of conceptually install it into memory and run it. The options on the end, -C-1 means don't cache anything, right? So it's really frustrating as a web developer if the browser starts caching stuff on you because you're changing code but it's running old code, or you're moving things around but it's still showing you the old files. So the -C-1 means don't cache anything, run the latest stuff, right? That's really important. You just made a change. It's the change you just made that you want to test. You care less of something you wrote 4 hours ago. But imagine if the browser is pulling that from the cache and you're not seeing your updates and you're driving yourself crazy. The -cores is about cross-origin requests and to allow them. Sometimes when you run this, it's HTTP server, so HTTP, but you might be pulling data from an HTTPS server, right? So that's called a cross-origin request, even if it's the same domain, right? It's a different protocol, and so in that. So it's basically to allow cross-origin requests. You can talk to other web servers to get data. You can talk to other protocols to get data. So NPX just means, hey, go get this node package, pull it down from the web and run it immediately with these options. -C-1, no caching, --cores for allow cross-origin requests. This saves you a lot of headache, those options on the end there. But it's pretty, if you got to get internet connection, this doesn't take too long and that sort of thing. So it's a way to do it. And again, it keeps your directory the directories of your project light because it doesn't install a node modules folder and download and permanently put a copy of the data there. But you're going to get the latest one with the latest bugs and that sort of thing. Right, and then you just go to, if you don't change any settings, you can change this port. You go to localhost on your computer, you'll see me do this in the demos, :8080, that's where the server is running. And it typically launches from the folder of your project or wherever the terminal opened actually in that. And if there's an index file, index.html file, it'll load that automatically. Otherwise, it'll show you a directory listing of the folder that you are in via the web browser in that. So I'm going to keep talking about the setup of the some more war advice. You could also install it into your project as well, right? And so this way you do get a node modules folder. So you'll see a new folder show up with lots of other subfolders and files, right? I think the overall size is not too big, but you'd be surprised. You'll be shocked by the number of files that get installed in that. So your project's going to be bigger in that. But the steps would be, that should be a small n. I'll fix that. That must be some auto correction thing. So lowercase npm, it's a node package manager. Init your project. So you go npm init -- yes. That will initialize your project as a node project. It'll make something called a package.json file will show up, and then that file tracks all the stuff that you've installed in that. Now the nice thing about this is VS Code's very aware of the package.json file, and you can edit it and stuff like that. And then another new menu option shows up to run npm scripts, which is nice. And so it kind of just integrates well into the VS Code IDE as well. So you get this little package, package.json file in that. And then you would go npm install HTTP server. This is where the node modules directory will probably show up for the first time. And you'll see lots, like I said, subfolders and files in there. And these are all the files that are required to run this web development server in that. But then once because it's not downloaded in random memory, it's all part of your project, and you do have this physical file on disk called package.json, you can actually add a start script to it and then save the instructions. So I'll show this in the demo. Start HTTP server minus C -1 hyphen cores, because otherwise if you, and then it's saved in the file, you don't have to remember those options anymore. Or you can come back and look at them because it's preserved in the package.json file. Otherwise, you got to have that floating in your head every time you want to run, if you do the NPX version of this. And then again, go check localhost. Again, the port, you can change that. There are port settings, so you can change it. It's probably it's probably -P. You can change the port number if you already have something running on 8080. So what you can do now is pause this video lecture and watch the lecture demo 1, where I show you me using the dev server. So what we're going to do now is move on to chart.js. That is the one that we'll be using in the lab. So we'll start digging in on that particular topic. So we're going to do a shallow dive, not enough slides for a deep dive in that. And the more you work with the API, the more undocumented features you find in that sort of thing. So where do you stop in that? So not enough slides for a deep one, I agree. So we're going to talk about chart types, and the C slides are coming up. Colors and fonts in that. Core data structures. I might spend too much time here. I just found, like, when I was playing around with it, I was trying to figure out, well, what's the best way to set up my data so that it slides into the chart more easily in that. And so that was a battle of trying a bunch of stuff, burning a bunch of time, but eventually getting, so what was my payoff? I got a lot better feel for how they do the data. I even got some suggestions for their documentation people, like to better describe people what the defaults are, and maybe even some tweaks to make certain things faster. We'll see, but they don't have to listen to me in that. There's 3 or more ways for data from what I can see in that, and we'll talk about it. There's options and plugins. The options get around if you did something really fancy with your data, you got to help out the API find the values. There's other things about setting up multiple scales that you'll do in lab and that. And so they do that through an options plugin technique. Even for title and subtitle for your chart, it's done that way. Tooltips and ticks. So I might, I've added some custom tooltips, and so I'll try to make sure that I mention those in my demos when we're looking at stuff. I just found one really simple stuff on pie charts. I said, well, I want to know what slice that is, and it's not in the default. And so then I went down another rabbit hole. But you know, that's how you learn things in that. And so tooltips and ticks as well. Ticks is something we do in the lab. I'll spend tooltips. Should I add more slides? Maybe, but it's really, we'll just demo them in the lecture demos and just point out the code and how that matches the documentation, because it took me a long time to understand what they're trying to do in the documentation. They're telling you this is how it's done, but then you're like, well, where do I put that, right? It's like, okay, so this is how you do it, but I have no idea what file to put this in and that sort of thing, and so I'll try to point that out in the demos as well. So I'll do a little chart tour, and when I do the demo, I'll dig into more of the background. Now I did the demos a certain way with the concept. I'm going to have a dev server. My data is going to be in JSON. I am going to use a promise over async await, although I'll demo async await for you in that. So, but let's just talk about the basic charts that you can do. So the idea is, like, if you want to, put a map in your app or put a chart in your app, what's a quick library you can grab to make that happen, right? And that's what this is really about, is, how can I quickly add this cool functionality to my web app, web mobile app, and just have that part solved. So I'm going to start with line. I was going to put these in alphabetical order, but then it didn't work because I think first you have to understand what a line chart is in that. And this is, we'll talk about the colors too, right? There's like a background color, and that border color, I think, and then there's color for fonts. But that's a line chart, right? So, and you can, there's, I think it's called tension. Like right now I'm not setting tension, so it's probably 0. So it's just connect the dot geometry, but you can like try to draw smooth curves through those lines. It has that as a feature as well in that. So the line demo is just, you're going to have, some data. There's going to be some data for the x-axis, data for the y-axis in that, and then you plot it. And it'll figure out the scale automatically for you. Here, notice I didn't have data that went all the way down to 0, so it lopped off the bottom part. But it might be important to you to always show 0. There's options to always go to 0 and that sort of thing. I think I do that on one of my radar charts, so we can take a look at that as well. When you go into the documentation, they go area charts, and then they immediately go, well, the line has a fill option, and they go, the radar is like area. So there really isn't a chart called area, in all honesty, but you can turn on the fill option on a line chart. And so here I'm filling all the way down to the origin. There's lots of options there about how you want to fill as well in that. And so an area chart is just a line chart with the fill option turned on, right? And there we go, right? Demystify that one for you. And so to understand an area chart, in this case, you got to understand the line chart first, because it's just a line chart with the fill turned on, right? This is a bar chart, right? So I think you can rotate these, if you want to have them rotated 90 degrees. And again, simple bar chart with fill colors. This is a bubble chart. Now some of the bubbles are bigger, okay? So besides the XY data, there is also some R data, radius data, how big to make the circles and that. So it depends what you want to show. I've seen this trying to show economic data, budget data, like where are we spending all our money, right? So you can visualize this big circle, what is it kind of concept. So there are 3 things going on here: X and Y to position the circle, and then how big to make the circle. I only showed half the pie. There's a whole bottom part of the pie. But a pie chart, right, all the segments, the angle is different because that tells you proportion, but the radius of the arc is the same on everyone. Now you might, that sounds totally crazy. Why is he talking about the radius? Well, there's another chart coming up where everyone's angle is the same, but the radius of the segment is different. So here, to distinguish between future charts coming up, a pie chart, the segment angle, right? How big is that slice of pie? Changes. Radius is the same. Donut just takes the center of the pie chart out in that. You can decide how big you want your donut to be. This is the chart I was talking about before, right? So if I count, how many I got? 1, 2, 3, 4, 5, 6. So it's 360 degrees divided by 6. All of the angles on those segments are going to be 60 degrees. But what changes is the radius. And notice that they're showing you the scale from 0 all the way to 250. So how much this pie slice comes out, right? That's how they try to show one slice is bigger than the other, right? So there's a different way to try to visualize. It's like a pie chart, but not. What changes is the radius of the slice changes, but the angle is the same. Where the pie is, the radius is the same on everyone, and the angle changes. So it depends, like what looks best for your data, right? And sometimes you just got to play around and see what works and what doesn't. Now, the radar chart is different, right? And so some of these, like, it's not really an XY thing. Pie charts and donut charts are and polar charts are not an XY thing because we're looping around in a circle. So what does it mean to have an X value? Okay, this radar chart, what does it mean? I mean, it's actually multi-dimensional axes. Each one of these, if you want to call them dimensions, there'd be labels in this particular uh, charting library. Each of these is a dimension. So how much grocery, how much restaurant, how much park. It's like breaking out of, hey, I have an XY axis. Here I can have as many axes as I want. And the concept is that depending how much, whatever that dimension is, or how you want to slice up the data, right? My concept here is, hey, it's a home, and hey, let's give everything a walk score. Walk score is usually between 0 and 100. How easy to get to grocery? How easy is to get to restaurants? And so every neighborhood or house you're looking at might have a different shape, right? And it's just another way to visualize it. One of the first places I saw this used, probably NFL Network, where they were comparing quarterbacks, how much they throw, how much they run, touchdown, interceptions, stuff like that. And so each quarterback had, it's funny because each quarterback had a very different shape to the polygon in that. And if you're comparing stuff, then what you do is you stack a bunch of these on top of each other. In that, really important to have transparent colors and that sort of thing as well. But you have a bunch of items that you want to compare multidimensionally. So there's multiple axes or multiple factors you want to look at based on a rating. Try to keep the ratings of each axis the same, otherwise you cause yourself problems. You get and this is classic thing in GIS. We may have different types of rating systems, but we have to normalize them to each other. So maybe we have a rating that's from 1 to 10, but we got to normalize it for like 1 to 100. And so we multiply it by 10. But we might have that concept 3 categories times it's 1, 2, 3 times everything by 33, right? Just to get them all the same sort of scale. And then we can map out this shape with the radar. Scatter, kind of like bubble without the radius, right? In that, that's a good little heads up. Those are tiny little circles with a set radius. Okay, so most what we think of as points, right? What we think of points in GIS are always faked with tiny little shapes, a little square, a little rectangle, a little star marker symbols. Here, these are tiny little circles. So they're like bubbles, but everyone gets, I use the exact same data too. Everyone gets the same size circle, and we just get plotted up. It's a classic XY scatter plot, right? That sort of thing. Just to get, hey, let's throw up the data. Not always, but sometimes you're looking for a cluster. Hey, there's a whole bunch of points packed over in this corner. What's going on? Kind of concept. That's not always how scatter plots are used. It's really up to the person visualizing the data. But, a lot of relation to bubble, right? In that. But the radius is fixed. And you don't have to set a radius on bubble. There's an extra information you have to send about how big to make that bubble. So what you can do now is pause this video lecture, and we'll spend some time on the demo 2 charts. I don't want to dig too much into the code because we're going to be doing that on future slides and that. Always pause this video lecture and watch demo 2, where I demo some of the charts. We'll lightly go over some of the code just so you understand the structure that I've done. But we'll dig into promises and the JSON in future slides. Now, before we can dig in deeper into the data for the slides, we've got to talk about JSON as data a little bit. And so, why JSON now? Because I thought it was about charts, but charts need data. And so how do you package the data for them? So once upon a time, the data was all HTML. There was no such thing as JSON. And then we had this movement to XML. And XML really hasn't gone away. I mean, because we have KML, Keyhole Markup Language, Scalable Vector Graphics, Geographic Markup Language, SOAP XML Web Services. So, you can run into some XML out there. Okay. But over time, I would say that the trend is JSON, and that's because of REST JSON. So if we're going to build something today, a backend that feeds data to our app, either whatever realm, desktop, web, mobile, probably going to send the data out as JSON. right? And if we're talking JS data, GeoJSON is pretty popular in that. Now there is this thing called protocol buffer format, but it's just JSON in binary just to shrink the size of it. But it's, it's just still JSON, that kind of stuff. Now the big thing about JSON, it is text, okay? So when you're breaking down JSON, there's only a few things, but it's amazing what you can pack in there. So curly braces means you're dealing with an object. Square brackets means an array. Key value pairs for the object are separated by a colon. Keys are typically quoted. That's the official standard. And there's a comma separator, and we separate keys from each other on the object that way, and we separate elements in the array from each other. Now that may seem simple, right? Braces, brackets, colons, commas. How could that possibly store all the data? We just mix and match, right? Maybe we have an object and one of the keys points to an array, or maybe we have an array of objects. And so that's how that's done, all that magic, right? Arrays just handle the concept of many. Objects handle the concept of a class in that. And so we can have a really big object with a bunch of arrays. With that array that has more objects, would have more arrays that have more objects in them. And so we just keep nesting endlessly. And basically, and that's all we need to do it. Braces, brackets, colons, commas, should add quotes in there, right? It's another thing you'll run into. The keys, typically at the JSON level, when you're programming in JavaScript, you'll notice that it doesn't enforce you to put them on sometimes because you're in code land there, and it's going, well, who's on the left and right. But in JSON, in case your key has a space or something crazy like that, don't do that. You gotta wrap them in quotes, okay? And then, like I said, you mix, match, nest, however you want. Right? That is how we can get a complicated structure like a feature collection in GeoJSON or an Esarai JSON feature set, which is basically the JSON text version of a feature class from a file geodatabase. Pretty close anyway. It's got SRIDs and all these other crazy things on it, column names, column types, domains. All of that is packed into this curly brace, square bracket, colon, quote, double quote, single quote, think double quotes is standard, comma, and with those characters, we're able to create this text-based structure to ship all this data from servers across the globe to mobile devices in the field, and have dots on a map show up. Okay. So we're dealing with JSON, right? I just wanted to give a heads up, and this is trying to feed data to these charts is where I came up with some categories. Okay, this is war stuff, so this is not in the chart.js docs. Okay, so it became obvious there is a group of charts that have a logical X and Y axes, and it may be implied, and they may not be upfront in your face. A scatter plot, X and Y is upfront in your face. Bubble chart, X, Y, upfront in your face. Okay, so there's an X and Y thing. Sometimes when we do like a bar chart, we're not realizing that the labels for the bars become our X axis. But it's an XY thing. Okay, line charts, XY. Line charts with area, XY. Right, so that's a whole bunch of charts that fall into this concept, right, of there's an X and a Y axis. In that, and so what am I trying to get at there? Because is that there is a directionality to it. Y increases as we go from the bottom of the screen to the top of the screen. X increases, even though people might argue, well, in the bar chart, is that really increasing? I'm not going to get into that, but X increases as we go from the left side to the right side. So it's all in there. So line area, bar, bubble, scatter, okay, definitely all have x-axis. So when you set the data up for these charts, there's some stuff you can do, right, in that. Now, if it's simple stuff in that, we'll talk about what it is, but I mean, it's two arrays, non-nested object, nested object. We'll talk about that. But the second group X and Y axis becomes kind of, well, maybe not, right? Because if it's this concept with X, well, as you move to the right, you're increasing, and as you move to the left, you're decreasing. What does it mean for a pie chart as we swing around a circle, right? So is that X really relevant? And then the Y, we're going, well, is it up and down? Well, it doesn't really apply to these set of charts, right? So the ones that it won't apply to are like donut pie polar, are almost like, in my mind, the same kind of chart, which whether you have a hole and whether the segments are the same size and their radius changes, or the segments are different and the radius is the same. That's donut pie polar. Boom. They're, for my mind, pretty similar charts. Radar's different. Okay, in that. And radar really has, like I said before, multiple axes. It's meant to be, well, we want to map this shape out with a whole bunch of axes that really aren't an XY thing. They're just all shooting off in different directions. If we had 4 dimensions, it would look like a cross. If we had 6 dimensions, right, they just shoot out. You just take the 360 degrees and divide it by the number of dimensions you have, and that's how many axes you're going to have shooting off in different directions. You want them scaled roughly the same in that. And so the concept of, hey, there's this X and Y that increases linearly, even though you don't have to do that as you move from the bottom to the top, it increases, and from the left to the right, it increases. That doesn't apply to these charts, right? The donut, pie, polar, radar. So they're set up differently, and the data is kind of set up differently in that. And that could be, when I was in the documentation, some of my confusion was, okay, well, why is this done so differently? Until I said, well, it's a different kind of chart. So that's why. Yeah. Because some of them you can, especially when you package the data, I don't want to say non-standard way, but maybe you want to package the data in a particular way and actually have extra information in there for the tooltips and that. Then you have to break away from the what they call the primitive way of doing it, or the basic way of doing it. And there's ways of identifying, well, now that we have this complicated structure, what part is the x-axis and what part is the y, until you get to these ones in the bottom. They're like, well, we don't really have an x and y. It's not that kind of chart. And so there's a different way of saying, oh, I put the data over here, right? Kind of concept. It explains the parsing on an object. So you don't, usually if it's a basic chart, you don't have to parse anything. It's really where you get into this, what you're going to feed the chart, instead of 2 arrays or a single non-nested object, you're going to send it an array of objects. And it goes, well, okay, where in the array of objects is the stuff for the X or the stuff for the Y, or where in the array of objects is the stuff that decides how big to make the radius on the polar, or how big to make the segment on the pie or on the donut, or how far to stretch out the polygon on the radar, kind of stuff. So where'd you put it, right? Because now I need some help because I can't figure it out on my own, which makes sense. So you'll see these parsing stuff basically in the doc. You'll see it in some of my demos in that. And so at this point, if you want to send a complicated structure, you got to give the API a little bit of help so it can find where you put the data, right, in that. So on the first group of charts, x-axis key, so that would be the key in the object that has, it's an array of objects. Objects have key value pairs. Which key has the X information? Y-axis, which key has the Y information? But then for donut, pie, polar, radar, the ISCO key, because the X-axis, Y-axis isn't a thing with these types of charts. And so you might be like, okay, why a different word? This is me trying to rationalize. That's what and speculation. That's why I think they change. Now, it'd be great if they had another little option to say, hey, this is where I put the value in that and stuff. We'll see. Or labels. That's what I'm trying to say. I would love to see a little thing in here to say, oh, I put the labels over in this key value pair. That would be a nice add to the API. And you know what? It may be dug in there really deep, but just not documented too. That's another possibility, right? So x-axis can work for labels for the first group. So if you're doing a bar chart, it becomes the labels, and that if you're having any labels along the x, it easily it'll go there first by default. That seems to be a default behavior. Not on the second group. I haven't found a nice little parsing value I could use to get labels. I had to write a little bit of custom code to say pull the labels from here this way, but it worked and that sort of thing. But the thing is, it could be in there. Just, you know, they could have it in there, but not have had time to actually document that this is how you do it. So we're going to talk a little bit about the components in that, just to break down the chart, because I've shown you charts. I'm trying to show you how they work. Now we're going to give you this information you need to actually make them for the lab in that. So what do you need to put it all together in that? So classic hooks, we saw this with Bootstrap and Leaflet in that. You need to hook in the JavaScript for chart.js, whether you download it locally or you have some big long CDN URL. You got to get the chart.js script hooked in, usually up in the head of your document. You need a style. Could have this in the external CSS file. That's what I would do in that. And this is really like how big to make your chart. We saw this with the map. We needed to have something that, and here we're using a canvas tag inside a div tag. I guess that seems to be standard operating procedure for this one. And so we just need to give the div a size so it knows how to sort of roughly approximate how big should the chart be in that. Here I'm using a selector, so I'm looking for a div with an ID called div ID. Right? So somewhere you got to have in your HTML document, in the body, a div. This is what they suggest, a div, and inside that div a canvas. The div we use for like sizing, styling. The canvas is what's actually going to hold chart. And then you need a little JSON function or something that, not JSON, but JavaScript script tag or external file that will basically create your chart and put it in that canvas div for you. All right, so we need some sort of JavaScript function that's going to go hunt all this stuff down, make your chart, put your chart in the canvas, I guess, inside the div tag in that. So some of the core structures that inside your script you'll deal with is the chart, okay? And it's an object. There's also something called data sets, okay? And the concept of a data set is almost like a series in pandas, right? It's we can have multiple lines in our chart. Each of those lines being drawn, say it's a line chart, can be a data set, one of the data sets in the data, one of the chunks of data series inside the data set in that. Now that data, right, I'm going to have to go over this a couple of times because it can look weird. Chart.data.datasets some array.data. So there's a bunch of stuff that have data on it, so it can get confusing, right? So you have a chart. Charts have data sets. Data sets have data. Data can be organized by you as two parallel arrays, a single non-nested object, an array of objects, which is the fanciest one on the end there, an array of objects. But then you got to help out the system sometimes to say, well, where'd you put stuff? It can make a bunch of assumptions with the two parallel arrays and with the one non-nested object, but it's going to need some help with the array of objects. And where'd you put it and what did you call it? Kind of concept. So there is this thing called chart.data, and that's not the actual data for a series. So that first data is not the data for the series, but it could be the title of the chart, the subtitle, right? An array called data sets that has all of the data for all the lines, right? Or multiple bar charts that you want to draw in that. So there is this thing called chart.data.datasets.data. And so what you have to do is just be aware, okay, which data am I dealing with? Am I dealing with like the high level chart data that has the title and subtitle of the chart? Or I'm down at one series all right, the data points for a that are being used to draw a line. Okay, so it's just unfortunately there's nothing I can do about it because I didn't make the library. I would use different words, but there is this chart.data data sets, which is a many. It's an array. You pull out one, and it has data arranged either as an array, a single object, or an array of objects in that. So there can be some confusion until you actually do a couple of these, and they go, okay, that you get the cadence, the rhythm of that sort of thing. Okay. Now there's lots of other things, right? So the chart object, the data set object, and the data itself. And then there is this thing where it's the chart.data.data sets. There's lots of other stuff too, right, that make up the chart. But the core thing is we're not going to get anything drawn until we figure out the data set chart thing first. And that colors are important. Okay, so the fill colors, what they call background color. We'll go through their official names, but you know, what color is the line? What color is the fill? What color is the font? Kind of stuff. Tooltips are nice because as you on hover over a pie slice, you can pop up some extra information or a data point in the chart in that. So definitely things that can enhance the experience. Fonts and titles, of course. What is it that we're looking at? That will always, if you don't do labels and titles, and people they don't understand what are we looking at. I have no idea what I'm looking at, right? That sort of stuff. So quick note on colors. There's 3 core colors, and these are the words you have to use. I understand that there's other words in CSS, but these are the ones that are part of the API. So the background color, so when we did that line/area chart, that fill color, or if you're doing a bar chart, the color of the bar, right, is called background color, right, in that. And so those are important. Background, yes, for pies, right, bars, radar, bubble, even scatter, because what's the color of the dot and stuff. Those fill patterns become important. Border color, line or outline, so the outline of a bar, the outline of a pie, but really it's really, I mean, the border color is used a lot in the examples for what color do you want to see that line on the screen. Okay, and then color for font. So there's background color, border color, color. Okay, and these are the words that you would have to set in JavaScript and the JSON to get things to show up on your chart properly. Now to specify color, red, green, blue, RGB function. There's an RGBA function. How opaque/transparent do you want it? And then there's also hex. If you know the hex colors, standard HTML colors that you want to use. Right now, you might, if you saw, hopefully, I went over it in the demos. My fake style that I've always put in. And that's really for triggering VS Code to pop a color chooser for me. So I have this one style called ID color chooser, and I use that to interactively set a color, because just guessing at numbers, I'm not good at that. So because the VS Code is a nice little thing. If you set a color, it'll put a little square next to it that actually shows you what the color is. And when you click on the square, you get the color chooser in that. So I can that's just trying to leverage stuff that's built into the IDE to make it easier on you for picking colors. So if we look at the basic structure of the chart object, that's what it is. There's like 3 key things on the object: type, data, options. Sometimes type and data is enough. You may the way you set up your data may slide into what the defaults of the API is expecting. And so the big thing about type is, well, what type is line, right? Bar, bubble, donut, pie, polar area. Beware of the capital A, right? Because it's case sensitive. Radar, scatter. And then data is going to be the data.data sets, right? Now it's chart.data. There's still two things called data that I mentioned earlier, chart.data, chart.data.datasets.data. So we're talking about the first one right now, chart.data, right? And that. And so chart.data, you're going to have labels, right? And this is usually shared on the x-axis. So the labels, if you set them, show up along the x-axis, like if you're doing like day of the week, month. But even if you're going to have like a numeric x-axis, that's how do you get those numbers on? Through labels. Notice that there's one set of labels. So the idea is that, and this is how they designed it, that even though we may ship, every time we ship the data for a particular data series and data sets, we ship the labels with it. They're only used once, right? And so that's why they sit up higher up here, is that we're going to label that x-axis one way, and then we're going to take the data from all your data set series and then plot them to compare them. In that, I use the term series because that's a term that they use in Panda to explain, like, if you're going to have 3 lines on a line chart, each of those is a series. So each of those will be one of the data things in the data sets. In that, and the values of a data set. So one of these data things in the data set, that's this chart data.datasets.data. Those are the Y values typically. But what if I'm in a chart that doesn't make sense? And this is where I started to have this, not quite an epiphany, but realization that there's definitely 2 groups of charts. One that have an obvious XY or work with an XY relatively well, and then the donut pie polar radar ones that doesn't make sense in that. And so there's this chart.data.labels, charts.data.datasets. Okay, labels are used once. Each data set can have its own Ys in that. So if we look at data, chart.data.datasets.I, what do you get? Right. And so usually if you only have one line to draw, it'll be dataset 0 and that. And so that has a bunch of stuff. It has the actual row of data that needs to be plotted on the y-axis, we say, or that determines the radius for the polar, or it determines the angle for a pie or donut, or it says how far to stretch out a polygon on radar. That's what those values are used for on the data. The label here is not along the x-axis, but if you're going to have 3 lines drawn, who's who, right? So that's like a name for that particular line in that. Notice we have border color, background color. If we're doing line, then that's the color of the line is border color. But if we're doing bars or something else, what is the fill color? That's the background color. Now the data above, right, is it an array? Is it a single non-nested object, key value pairs, or is it an array of objects, right? And so typically if you have an array of objects, we might, and we're not using standard, I guess, default names that aren't quite that well documented, then we might need to help out with the parsing options. So the chart.data.datasets@I.data, right? Like I said, 3 options, 2 parallel arrays. One is used for labels, one is used for your Y values. Okay. A non-nested object with key value pairs, if it sees that, it assumes to use the key name as the label and the value for the Y. Seems to do that automatically in that. And then yes, so keys become labels, right? Automatically, without you having to tell it too much, it's able to figure that out on its own. And the values are for the y-axis, pi segment size, that sort of thing, radius, an array of objects, right? And so, in here, there's an array, many, but there's objects. And this is where it might need some help, but you'd be surprised when you look at the scatter and the bubble. There's some unspoken defaults in that. So options.parsing help the API find your data. So in this array of object, inside this particular object here, right, which key value pair has my stuff for the X, which key value pair has my stuff for the Y, or which key value pair has my stuff, for the pi, for the polar kind of concept. So unspoken data structures, just so you know where. So when I was burning through some of the examples, actually making each one painstaking as it was, right? I noticed that there was some like defaults where I didn't have to talk about parsing, right? So especially like bubbles where it first popped up for me. There's an array of objects that the sample feeds it, but I didn't say anything about options parsing. This is how you break data up. So I noticed that in their sample, they were using an array of objects, and they had a key value pair called X, Y, and R. And so it knows on its own to use the X for the X, the Y for the Y, and the R for how big to make the bubble, right? I didn't have to explain to it. So there are some unspoken, maybe soon to be documented defaults, and that you just have to play around and that sort of thing. What you can do now is pause this video lecture and watch the third demo where I play around with different data structures to make basically the same chart 3 different ways. Talk a little bit about async data requests. So in terms of async requests, you have 2 or 3 choices, we'll say. There's the old school XML HTTP request. This was invented way back, and that before promises and await. So, and in the end, it might be doing this in the background anyway, and it might just be hiding it from you. Old but still used. Takes a lot of code though. You got to write a lot of callbacks and stuff. The promise is not bad. It is the one I use predominantly in the lab demos. In that, so we'll dig in a little bit deeper in that. It's more modern in that. One thing where you might see it show up, I think it is elegant compared to above and what I'll show you below. Or it's the one I'm used to, maybe. Maybe I have recency bias in that. But basically, the promise shows up also in the EaseWrite JavaScript API version 4 and higher. So not 3, but 4 and up is where they started using promises. So it is sort of a terse, kind of interesting way to get some data, process it, handle stuff if there's some errors in that. There's async await. This is new in that. I mean, it works like promise. I'd say promise is more of a Wild West JavaScript, way of doing stuff that's got smoothed over the years, so it looks kind of okay. Async await is more like very linear, stepwise kind of concept that you might see in other languages and that. So async await is the most modern, but it's kind of noisy, and it does look weird from what we're used to, right? Because we're used to other ways of doing it. It isn't bad. The one example in the lab, it's interesting because there's a lot of stuff going on with the CSV file. The one I'm going to do in the demo is I've cleaned it up to try to just really focus on the lines that are doing the asyncing and the waiting in that. Looks horrible and confusing. Yes, I did. It's really interesting like I said, if you watch the parody of the JavaScript developer, but even more the reaction to that parody. They will mention async and promises and people rewriting code and then going back to promises because, after doing because I did this myself, I did the async await on a Node Express framework app. And then I said, no way, and rewrote the whole thing back as promises because I went through the exact same experience. So what you can do now is pause this video lecture and watch the demo where I show a promise. It is the main technique that was being used in the earlier charts as well. Again, you can pause this video lecture and watch demo 5. It's basic, same chart, same data, just changing how we're writing the code. And I will say, I will leave it up to you. I mean, whatever one, the promise thing, I'm used to it because of other areas, so it clicks for me. Whatever, maybe the async await clicks for you. So I would be okay with whatever technique you choose, because it's whatever works for you in the end. Like if the async await makes total sense, then go for it, is what I would say. Otherwise, use the promise. Switch gears and talk about the DOM. So the DOM, Document Object Model, that's what it stands for. But what is it? So it's a little bit of a mouthful, but it's that in-memory representation of the HTML loaded in the browser. So the HTML is just a file on disk that gets, sucked into the browser and then displayed. But then we don't go back to the HTML file and replace stuff in there and reload the page. People actively just go to the DOM and change stuff. So when we go find a div or find a canvas and put a chart on it, that's just DOM manipulation in that. And a lot of the Vite, Snowpack, hot module replacement is all done by tweaking the DOM. That sort of thing. It is the basis for of reactivity. So you hear response, that's just your app moving stuff around so it looks good on a phone, tablet, or desktop. Reactivity is about, hey, when something changes data, update the table, update the drop-down list, change the text on a page or something like that. That's how, so that reactivity is about when data changes, make sure it, changes in memory, that also changes like on the screen so the user can see it as well. Yeah. So, a lot of the DOM is how to find things, because you can't change something until you find it first. So you got to find it, and then once you find it, you can change it. Kind of concept. I hope that makes sense. The key object is document. So that's built into the JavaScript API. It's going to work across browsers. So if you need to find something, you go, there's lots of ways to do it, but one way is document get element by ID. Now, the way to use this one is like you're really trying to hunt down a unique thing, right? So there should only be one map on a page. I'm not saying that, but it's about uniqueness when we're going by element ID. That's the concept anyway. But there's also get element by name, get element by class name, which helps with like styling on a lot of frameworks. Get element by tag name, get element by tag name namespace. So there's lots of ways to get an element, but that's how you find something. Just get element ID, typically used to say a unique thing on the page. But you might be like, hey, go get all the H1 headers and do something different with them, right? That's a different type of thing, update their style, that kind of stuff. That would be like find by class name or maybe find by name, depending how you did that yourself. How to change, there's lots of stuff. It depends what you got. If it's a div, you change the inner HTML. It's pretty standard. You can just write, you could always just write to the browser, document.write, to send stuff right into the browser in that. But let's say you get a drop-down list and you want to add options to it. So you get the select.options.add and then add options to your drop-down list. And so then at that point, when I'm showing the select here, it depends what control you get, how you would change it and that sort of thing. So who uses the DOM? Why do we have to use the DOM? Frameworks definitely use the DOM. So these frameworks, right? Just to, Vue, React, Angular, and others, very popular because they're, reactivity frameworks. When data changes, they update the page, single page apps, that sort of thing. And so there's lots of state stuff. They have to manage things turned off and on. They can't forget that they did that. And if there's changes in code, they need to toggle the flip in the interface or something. So they, some of these even have what's called a virtual DOM. I think Vue and React use a virtual DOM in that. They make the changes there first and then change the DOM after. It all depends. So some development servers like Vite and Snowpack have HMR, hot module replacement. So not only do they do DOM stuff, well, part of the DOM is what sources you have loaded. So the idea is that you're in VS Code and you change some JavaScript, you change some HTML. Say you have autosave on in VS Code. So as you're typing, it's auto-saving, and you can see your changes appearing in the browser. You're not hitting the refresh button or reload button, that sort of thing. So it's hot module replacement. That could even be JavaScript code. That's a little bit trickier. Swapping out some HTML is one thing. Changing the code under the hood and making sure that the latest code is in the browser in that. But it really speeds up that, write, test, debug cycle, which is so important, is to get that happening fast. And so you can make an update, fix something, move forward, right? So as you type in VS Code, it automatically appears in the browser. No refresh. It's great. So Vite does this, and Snowpack does this as well. Now we'll change the noun-verb agreement to appears after. So we're going to talk about JavaScript loops, and that there's a bunch, and there's some even built into other structures. So you may not even need to write a loop depending on what you're trying to do. So there, well, you have some options, that's for sure. We're talking about looping. You got old school loops. So you got the for, right? I is equal to 1 or 0. I is less than something. I plus plus. Usually starts at 0. So I'll have to fix that. You'll be off by 1 often. But it may never fire because there is that test condition. It's what's called a pretest loop. So test the condition first, and if it passes, we go, and if we don't, we don't. And we're out of the loop. It could be for a key in an object. The keyword in. So when in is about objects, for every key in the object, do something. And that is also for one of the many. So for one of the elements in the array. And so of is for really about arrays. So you need to cycle through everything in an array. And that there's so if you need to cycle for all the elements in the array, it's good for that. There is a while loop as well. It's also a pre-test condition loop. All the fors are pre-test. The while is a pre-test. The conditions are tested first because these things can be empty. So the code in all of those may never fire. There is a do while loop. And so this is called a post-test loop. You're going to run through the loop at least once, and then you test the condition. And so you have to decide, well, are we always going to run through at least once, or is it possible that we may never run because the object may be empty or the array may be empty or something like that? And it all depends on you. The trick about the while, do while, the last one, is this little extra semicolon here that can throw people off, right? So we'll fire once because it's post-test, right? Runs the code, then it tests. All the others, technically, when you dig through them, they are pre-test loops. They check the condition first, and only if we pass that condition do we execute the code inside the loop. Now, there's some other ways to loop. So if you're dealing with an array, there's some built-ins that are kind of interesting. So arrays have a built-in loops in that. So let's say we have like var junk 1, 2, 3, 4, 5. So we can go junk every in a function. Now this function is different. It's going to apply a test, and if everything in the array passes the test, you'll get true back or you'll get false back. So if one fails, it's out, right? It's almost like in SQL in databases, it's the any operator, all operator. Yeah, they all have to meet the condition, okay? And that sort of thing. So just be aware of what is it return, a true or false on whether the function is going to test each of these values. But if any of them trip to false, then it's over. Filter is kind of interesting. Again, it's going to return an array to you, but a reduced array, right? So give me everything greater than 3. So 4 or 5 would come back, right? So it depends in your function what test you apply. But the concept is that you're going to get an array back, and often the array will have less elements than what you fed it because of the criteria. For each is it's a different one. It could be used on the assignment even if you want, but for each is just going to run off a function. So for every value in there, it's going to run the function, right? So it's going to run the function with 1. It's going to run it with 2. It's going to run it to 3, run it to 4, run it to 5. Who knows what it does though? right? It can go off and do anything, right? It's really up to you in that. Reduce would say, reduce is just that. It's going to take all of those values in the array and return you one thing. So it starts with an array, but the concept is going to return you one thing. So a lot of people use it to sum up, do an average, right? I need to average all those values, kind of stuff in that. But it reduces the array down to one value, right? Returns a single value. That's the concept. Map returns you an array the same size. So say I need to take each of those values and cube them or square them or divide them by the same number. I'll get an array back same size with that operation applied on each of those. Okay. Returns a results array, right? But the key is it will be exactly the same size. This sounds like wonderful multiple choice questions, by the way, and that sort of thing in that. And so the big one is a lot of these return, but that for each one just calls the function. The function may not return anything to you. You'd be off doing something else on the system. So you can use the for in, for of, while, do while, right? Because on the assignment, you have to loop through some JSON data and make a table. So for, for every row, do something, right? And so you could use one of those for loops, or you could try call, if your data is already in an array, you could try, or you quickly convert your data from whatever it is to an array. You could try using a for each, a map, or something like that to have something happen. So what you can do now is pause this video lecture and watch my demo 6. I'm going to go through an old school for loop, the for in and the for of, and I'll do some fancy, overly complicated fancy stuff with the map function on an array in that. Not sure if I would really do this in real life, but it's in the demo. So I threw this in because this might be important if you're doing any kind of area charts or line charts and stuff. So there's different fill modes in that. The one I used would have been the second choice boundary, where I said origin, fill down to the origin in that. But you can also fill to another data set, so fill in the area between two series in that. And you can do it like based on a relative position, and that you can. So there's lots of different, I guess, ways to fill in that. Just so you know, so either to another data set or all the way down to the origin, are classic ones, or a particular axis value, and that might, so say you had like some threshold line that you wanted to accent, and how high are we above that threshold? That's one way to do that. So those fill options can be important depending what you're trying to do. So if you have any questions or need to re-examine a topic or need to get clarification on a term or concept, you can get an answer by posting a note on the discussion boards for this course. That's all for now.